All right, here we go. Welcome everybody to section 1.6. And in this section, we're going to learn how to solve polynomials of higher order, like maybe x to the third power or something like that, using some different techniques that I'll show you. And then we'll also learn how to solve equations that are quadratic, but they don't look quadratic. And I'll show you what those look like. And then we're going to work on radicals. So example 1, we want to find solutions to this equation. Okay, but remember, as I said before, we always have to make it equal to 0. So I'm going to add 5x to both sides. And what that will give me is 3x to the third. Sorry, this is squared, plus 5x squared minus 2x equals 0. Perfect. So now we have turned it in our equation into something that equals 0, which we have to because of the 0 multiplication rule. So next thing we're going to do is we're going to, remember I said the first step always whenever we factor is going to be to find the greatest common factor. And the greatest common factor basically is what I can divide each one of those numbers by, 3x to the third, 5x squared, and minus 2x. And if I divide by x, then all of them will still not be in fractional form, right? So that's greatest common factor is going to be x in this case. I factor out an x, and then to do that, basically what I'm going to be doing is taking, in case anybody's confused, if I divide each one of these by x, and multiply by x, right? It's the same thing. So I'm going to multiply by x, and then inside I'm going to do the division. So 3x to the third divided by x is 3x squared. And then plus 5x minus 2 equals 0. And now we have to factor that 3x squared plus 5x minus 2 because it's not in its simplest form. So again, we're going to do the steps we did to factor before, right? So step 2 is, and remember I have to find A, B, C. So A here is equal to 3, B is equal to 5, and C is equal to -2. So I want to find two numbers that multiply together to give me A times C, and A times C is -6. And when I add them together, it equals B, and B here is equal to 5. Okay, now let's make our table. I need two numbers that multiply together. First, I worry about the 6. So it's 1 and 6, 2 and 3. The next number would be 3, but I already have 3. 3 and 2, and 2 and 3 are the same. And now I have to make my 6 negative. But remember, when I add these two numbers together, they've got to be positive 5. I'm going to have to make, since 5 is when I add them, I'm going to make this side negative because when I add these two numbers, now I get 5. So these are the two numbers that I need. Okay. So now that I found that, let's go to the next page. So we have 3x squared, and we have our -2, and we're going to use these two numbers to get our 5x. So that becomes -x plus 6x, because this is really minus 1 and 6. So if I add these two together, I get my 5x squared. Okay, now let's go to the next page. Let me copy this. And we'll paste it into our new page. All right, so now I'm going to factor by grouping. So I'm going to group the first two together. I always put a plus between them, and then I put the second two together. All right, so what are we going to do? In the first group, we look for our greatest common factor, which is x, right? And if we factor out an x, we get 3x minus 1. And then I have my plus. In the second group, I want to factor out the greatest common factor, which is a 2, because 6 and 2 are both divisible by 2, and I get 3x minus 1. Perfect. Now, I just factor out my 3x minus 1 from both terms, and I multiply by x would give me the first term, and plus 2 gives me the second term. So now I've factored, right? But don't forget, our original was x times 3x squared plus 5x minus 2. So my factors of my original equation, which was, originally I had 3x to the third plus 5x squared minus 2x equals 0. And then the first thing I did is I factored out an x, and I ended with 3x squared minus, 3x squared plus 5x minus 2 equals 0. And then we factored this 3x squared plus 5x minus 2, and we got, so this is x times 3x minus 1 times x plus 2 is equal to 0. And so now we're going to use our zero multiplication rule, except now we have three things multiplied together, a, b, and c, right? So that means either a or b or c have to equal 0 so that the combination equals 0. So what do I get? I get for a, I get x equals 0. And there's nothing for me to solve. It's just x equals 0. The second one, we have 3x minus 1 equals 0. I add 1 to both sides. I get 3x equals 1 and divide both sides by 3. And I end with x equals 1/3. That's my second solution. And then my third solution, 1, 2, and my third solution is x plus 2 equals 0. Subtract 2 from both sides, and I get x equals -2. So that is my third solution. So this problem has 3 solutions. Okay, now let's do something where we have 4 terms. Well, we've never actually seen something with 4 terms to begin with. We've created 4 terms every time we do the factor by grouping. Notice we go from our 3 terms and we turn it into 4 terms. So now we start with 4 terms. So whenever you see 4 terms, the first thing you should think is, can I factor by grouping? So let's see, because I can't, if I look for the first thing I'm supposed to do, which is find the greatest common factor, well, I have 2x to the third plus x squared minus 8x minus 4. Maybe what I should do is show you how to find the greatest common factor, because I don't know if everybody knows, and It is something that's very important. So basically, if I were to look at this and I want to find, now let me give you a different example. So let's say I want to find the greatest factor. I'm just going to put in a new slide. Here, I'll put in a new slide, how to find greatest common factor. And if you know how to do this, you can just skip ahead. Greatest common factor, which we call GCF. So the first thing we always want to, so we're going to actually do it in reverse. Let me think of a good problem that we can use. How about if we use 6x to the 5th um, 15x to the 3rd and 12x. So it doesn't really matter. Those are my three terms. We can put pluses or minuses between them. I'll just put pluses. It doesn't matter. But we're looking for the greatest common factor between those three numbers. Okay. So what I want you to do is we're gonna do what we're gonna say, only we're gonna go in reverse. First thing I'm gonna do is I'm gonna factor each one of the terms. So for example, I have 6x to the 5th. And if I factor it, 6 is really just 2 times 3. And then we have 5 x's. Okay. The next one, we have 15x to the 3rd. And 15 is 3 times 5. Those are, but we factor down to prime numbers. And this gives me 3 x's. And 12. Well, 12 is going to be, and for this one, I'm going to show you how to do a factor tree because there's a couple more factors. So if I start with 12, I want two numbers that multiply together to give me 12. I can just say 3 and 4. I can say 2 and 6. It doesn't matter what I start with. It'll always come out the same in the end. And 3 is a prime number. And then we have 2 times 2. And those two are prime numbers. So now I know that 12x is equal to 2 times 2 times 3, and we only have 1x. So now we've done the F for factor, right? So we factored. Now the next thing we want to do is find out what they have in common. Okay, well, the top two have a 2, but the middle one doesn't have a 2, so they don't all have a 2 in common. But they all have this 3 in common. Notice they all have a 3. And they all have an x. And that's pretty much it, because the 6x to the 5th is only left with 2 and 4 x's. The 15x cubed is left with 5 and 2 x's. And the 12x is left with 2 2's. And there's nothing that I can circle that has everything in common. So here I would say my greatest common factor is, and I multiply the things. So I just want to make sure you understand. So we have a 3 in common and an x in common. That means our greatest common factor is 3x. Now, if we were just asked for a common factor, 3 is a common factor. 3 is common to all of them. X is common to all of them. But the greatest common factor, I find the things that are in common to all of them, and then what I do is I multiply them. So I found 3 and I found x. My greatest common factor here is 3x. So hopefully that helps with some of you who are having problems with finding greatest common factors. When I look at these 4 terms, well, I can see that they don't all have an x. That's done. And then the first one is a 2, but the second term has a coefficient of 1, and there's nothing in common between those. So since there's nothing in common between those, there can't be anything in common with all 4. Hopefully now this makes a little more sense to some of you who may be struggling with greatest common factor. So we're gonna factor by grouping because we have 4 terms here. So 4 terms, factor by grouping. So we start with 2x to the 3rd plus x squared. And then again, put a plus between them. And we have minus 8x minus 4. And that equals 0. Okay, now in the first group, we want to know what the greatest common factor is. And from before, we can see that if I factored this, I would have 2 times x times x times x, and this would be just x times x. So what they both have in common is x squared. So I multiply this by 2x plus 1. I have my plus. And now I'm going to factor out my greatest common factor. And remember, I never want the leading term. So minus 8x is the leading term. I never want that to be negative. So I'm going to factor out a negative. And 8 and 4, the greatest common factor is 4. And if I do that and divide each one by negative 4, I'll get 2x plus 1. Okay, and again, this equals 0. And as we've done many times, our greatest common factor between those two terms is 2x plus 1. And then I really just pick my outside numbers, x squared minus 4. But now we have this x squared minus 4, and that's not factored all the way down, because this is called the difference of squares, and there's a couple of ways you can do it. So let me see. I think what I'll do is I'll take a new page just so I can show you. So if I have x squared minus 4, I can use my square root property, remember? My square root property says I add 4 to both sides and I get x squared equals 4. And then I take the square root of both sides. So we get x equals, and whenever I take the square root of both sides, I have to make sure I do my plus or minus, and the square root of 4 is 2. So my solutions to this are x equals plus 2, x equals minus 2. So that's one way to do it. Also, the other way is just to know if you have a squared minus b squared equals 0, which I have from that equation, I can say a is equal to x and b is equal to 2, and then I have x squared minus 4, right? This always factors to a plus b times a minus b, and these are called conjugates. I'm not going to test you on vocabulary, I'm just telling you. So my example here would be, I have x plus 2 times x minus 2 equals 0. And now I can see my solutions are x plus 2 equals 0, or x minus 2 equals 0, which gives me x equals negative 2, or x equals positive 2, which is exactly the same as what I got here. Okay? If I were to want to factor more, I could say this is 2x plus 1 times x plus 2 times x minus 2 equals 0. I already found my solutions to 2 and minus 2. So basically, I'm just going to say let 2x plus 1 equal 0, or x plus 2 equals 0, or x minus 2 equals 0, which gives me, so if I subtract 1 from both sides, I get 2x equals negative 1. Divide both sides by 2. And here I get, let me write it over here, x equals minus 1/2. That's one of my solutions. And then this one would be x equals negative 2. And this one would be x equals positive 2. And there's my 3 solutions, okay? So that's how we do this example. And here is some of the work we did. Now, let's look at another solution. Okay, so this looks a little different because we only have 3 terms, but we have a to the 4th and squared and nothing power. So this is something that's a little more complicated, and how I can show you so that you can see it more easily how to solve this is if I just use a letter U, and I'm just making it up, it doesn't mean anything. I'm going to say U equals x squared. And then what would U squared equal? U squared would equal x to the 4th, right? Because I would have to square both sides. So it would be U squared equals x squared squared, and that gives me x to the 4th. So now what I'm going to do is I'm going to replace x to the 4th with U squared, because that's the same as x to the 4th, minus 11 U, because we said U is equal to x squared, plus 12 equals 0. Okay? And now we do have a quadratic, and we can either solve this using the quadratic formula, or you can factor. I'm going to keep factoring because I think you guys probably need the help and the like the repetition. I can solve it using the quadratic equation. I think you can too, but maybe we'll do this both ways. So first thing we want to do is what? Remember? Yes, we want to look for the greatest common factor. And 2, 11, and 12, they have no factors in common. So there's no common factor there. And then we have U squared U and then nothing. So again, we have no common variables. So we just say our greatest common factor is 1, and then we go to the next step. And my next step is I want to find 2 numbers. When I multiply them together, gives me A times C. And here A times C, again, I'll write down A equals 2, B equals negative 11, and C equals 12. So A times C equals 24, and M plus N, well, that has to equal B, and my B is negative 11. So we'll make our table. And 24 has a few factors, 1 and 24, 2 and 12, 3 and 8, 4 and 6. 24 is not divisible by 5, so I don't have to worry about that. And then the next one would be 6, but I already have 6 and 4, so I don't have to worry about it. Now, 24 is positive, so let's add these 2 together. We get 25, 14, 11, and 10, right? I know this is my number right here because there's my 11, but it has to be negative. So 2 numbers that add together to give me a negative number, multiply together to give me a positive number, they both have to be negative, right? So I found my 2 numbers, and so now what I do is my third step, I take this problem. So I'm working on this, okay, first. So I say this is 2u squared, and then I have my plus 12, and then I use my minus 3u minus 8u. Those come from these 2 numbers, my m and my n, okay? And we'll finish factoring. I'm going to group my first two terms, 2u squared minus 3u plus minus 8u plus 12. Okay. In my first group, what's my greatest common factor? Hopefully you thought it was u, because u is my greatest common factor. And then I get 2u minus 3. Now I have plus, and what's my greatest common factor in the second group? Again, remember, we want to take out that negative because I don't like my leading term to be negative. And these are both divisible by 4. So this becomes 2u minus 3. Perfect. How do I know it's perfect? Because they both have the 2u minus 3's. So now I pull the 2u minus 3 out, and I end up with u. And then plus minus is just minus. These are multiplied together, minus 4. So now I've factored that the one that I changed the u to, I factored it into my factors, but I want to know what x is, not what u is. And u equals x squared. That's what I said is u. I'm going to make u equal to x squared. So here, I'll write it here. U equals x squared. So if I want to know what x is, x, I take the square root of both sides, right? And I get x equals plus or minus the square root of u. Yes? Hopefully that makes sense. And then, well, actually, this we're going to save for a minute, because first I'm going to solve for u. So I have, and this equals 0, so I have 2u minus 3 equals 0, or u minus 4 equals 0, which gives me, I add 3 to both sides, I get 2u equals 3, divide both sides by 2, and I get u equals 3/2. That's one solution. Or I add 4 to both sides and I get u equals 4. Okay? But I don't care what u equals. I want to know what x equals. So I substitute, actually, let's just do this. I'm going to substitute x squared in for u. So I have x squared is equal to 3/2. If I want to solve that, I take the square root of both sides and I get x equals plus or minus the square root of 3/2. Okay? Or, again, I substitute u equals x squared. I get x squared equals 4, which means that x equals plus or minus the square root of 4, which is equal to plus or minus 2, right? And I have, let's grab the bottom again. So now we have, well, this is pretty obvious. Here we have x equals 2 or x equals -2. That solves that equation. But we don't really like to have radicals in the denominator. So if I start with the square root of 3/2, that's the same as the square root of 3 over the square root of 2. I don't know if you remember me saying, but with radicals, I don't know if I actually did say this, with radicals, I think we did this during the quadratic formula. So when I have radicals, as long as it's multiplication or division, I can just multiply, I can separate them, I can put them back together. And what I want to do here is rationalize. So rationalize means I don't want the square root in the denominator. I want the denominator to not have a radical, okay? So I can multiply. Well, to get rid of this radical, I would have to multiply by the square root of 2, because the square root of 2 times the square root of 2 is the same as the square root of 4, which is 2, or the square root of 2 squared, which is also 2. So I'm going to multiply both of these, the top and bottom, by the square root of 2. And now I multiply across the top. So I get the square root of 3 times 2, which is equal to the square root of 6. And in the denominator, I get the square root of 2 times 2, which is equal to the square root of 4, which is 2. So I've now rationalized my denominator. I started with x equals plus or minus. So we started with x equals plus or minus the square root of 3 halves. And we've turned that into, by rationalizing, the square root of 6 over 2, which means I have, again, two solutions. Square root of 6, positive the square root of 6 over 2, or x equals negative the square root of 6 over 2. So now I have 4 solutions to this one problem. Okay, so I know that was a little different. Maybe you've never seen anything like this before, but I have these 3 terms, and I can, if I look, I can see that if I square, so what I'm looking for is if I square this, do I get this? And I do. If that happens, I can use substitution to make it look like a quadratic equation.